Hello, this module will have two parts and I'm going to talk about two pitfalls, common pitfalls in understanding probability distribution. Now in this module I'm not teaching you the probability distributions, PDF, CDFs and such. I'm assuming you studied them. However, in my practice I noticed that these two pitfalls they are they are not uncommon even among people who studied probability at some level. And these two are, I'm going to say the first one is that PDF is not a probability. Well, that's a correct statement. PDF is not a probability, but I've met people, and I'm going to show you an example where people think it's a probability. And the second pitfall is getting confused about countable and finite. So first we will talk about probability density function and the fact that it's not a probability. There is this video on YouTube and it's quite characteristic. That's why I brought it up here. You can find links to both points in this video where they make both of these mistakes, right? 1 and 2, just check the URLs and watch the videos themselves. But what was striking in this video to me was that this is a bionic turtle, and I know that this resource is very popular among people who prepare for FRM certification exam. That is GARP's certification on risk management. There are two most popular risk management certifications in financial industry, and one of them is FRM and the other one is PRM. So I took the PRM one, but I have colleagues who took FRM. So Bionic Turtle is quite popular, and that's why it was I never took this course myself, but I was very surprised to see such a confusion in the instructional video. So first let's just briefly mention what is the definition of PDF and CDF. I'm not trying to define it here, but I'm referring you to one of my favorite books. It's Feller. It's called Probability and Its Applications. I'm giving you the URL. This is not a pirate URL. This is a legit URL on an open source book, right? It's volume 2, second edition, page 168. So these few lines, literally I think 7 lines, that's all the definition of PDF and CDF that is given in this book, and it's a seminal book. It's very important in probability theory, I would say, as a textbook. So let's go and jump into the discussion of the first pitfall, right? PDF is not a probability. That's what I'm going to state here. And if you go and watch the video at that first point, it's about 4 minutes in, right? 2:38 seconds. The instructor is literally saying that PDF is a probability of a point being between 2 points. Like basically, you pick an interval somewhere, maybe around x, and then PDF is a probability that your random variable is in this interval. Wrong. Absolutely not, right? PDF is a density of probability. PDF is not a probability, right? So this 2% is incorrect because PDF's unit of measure is not the probability at all. A horrible mistake, right? Okay, so let me correct this very quickly. The probability of a value being inside an interval, right? Okay. So let's look at the intuition of PDF. Again, I'm assuming you studied PDF, but let's just refresh the intuition. So there are several ways of defining PDF, and here I'm starting from CDF to emphasize the difference. CDF is a cumulative distribution function, or as Feller calls it, distribution function. Often it's denoted by big F, sometimes Greek F. So F as a function of X. CDF means what? It means that your variable, random variable, it's a probability that your random variable is lesser or equal to that given value of x, any given value of x. So in case of a normal distribution, think about this. It's a symmetric distribution around 0. So what is the probability CDF, the big F of 0? Think about it, CDF. Of course, it's half. It should be 50%. It's a symmetric around 0, right? So there's 50% probability that it'll be lesser than 0 and 50 that it will be greater. So I'm asking what is CDF? CDF is a lesser. Answer must be 0.5. And 0.5 is a probability. This is the probability. CDF unit of measure is the probability. What's interesting about CDF also is that when you run your argument of the CDF function from minus infinity to plus infinity, your CDF runs from 0 to 1, right? If you think about maybe negative infinity number, well then there's very unlikely that any number will be lesser than your negative infinity, so you have a probability of 0. And conversely, if your x argument of the CDF function is positive infinity, then all the numbers are going to be lesser than that infinity, so you get 1, right? So it goes from 0 to 1, never goes down, right? It's always going up, so it's non-decreasing function. That is your CDF. Now, what is PDF? Well, the PDF is a density of this probability of the PDF. It's a slope. It's a first derivative of the probability CDF function, cumulative distribution function. And that is why, look at this. In numerator, you have probability, and denominator, you have what? You have x, your variable. So if your x is, let's say, in kilograms, then your density will be measured in probability per kilogram. If your x is in yards, then F, the PDF, will be measured in in probability per yard. Right? So this is the PDF, probability density function, is not a probability. It's a density. And unit of measure is probability per unit of x, whatever is your x. Usually x is a unitless value. So in probability, in statistics, it's oftentimes we use some abstract x, some 1, 2, 3. We never say what is it. And that's how I think people can make this mistake, thinking that PDF returns you the probability. No, PDF does not return you probability. How do you get to probability? Well, that interval thing which they discussed in the Bionic Turtle video works like this. What is the probability that your random number is between, let's say, some x and x plus delta x? So your random number is in interval of the width of delta x. It could be narrow interval, it could be wide, but what is the probability? Well, you get the density and multiply by probability, by the interval width, right? So it would be almost like, yeah, I won't go into like density, physical densities, but it's very close to notion of a physical density, right? So to get to probability, you always need an interval. You need to get your probability density function and multiply it by an interval. You always need an interval, right? This delta x. So I think on that we can yeah, we can wrap this first point, right? So PDF is not a probability. Just remember, it's a density of probability. It's a probability per unit of your variable x, right?